Okay, so we're going to look at an example problem on charged interaction. So interaction of charged particles. So this problem reads three objects are brought close to one another, two at a time. So we have object A, object B, and object C. When objects A and B are brought next to each other and released, they repel one another. When objects B and C are brought next to each other and released, they repel one another. What can we say about the relative charges of each of these objects, and what will happen if I bring object A to object C? All right, so the first experiment tells us that when object A and object B come together, are brought together, they repel one another. So we learned in our mini lecture on interaction of charged particles that like charges repel. Well, if we're seeing an observation of repulsion, then object A and object B must be of like charge states. So we have three charge states, remember: neutral, positive, or negative. So object A and B have to be the same. They could be both positive. Object A could be positive and object B could be positive. That would cause a repulsion. They could also be both negative. If object A were negative and object B were negative, well, they'd also repel. But what about neutral charges? Can object A and object B be neutral? Well, if I put two neutral charges together, what did we learn? They don't do anything. They don't attract, they don't repel, they just sit there. So because they repel in this situation, we know that A cannot be neutral, nor B is not neutral. Because what if they were neutral? What if one was neutral and the other wasn't? Well, neutral objects attract to charged particles. So, since I get only a repulsion, neither one of them can be neutral either. All right, the second scenario told us that object B and object C are brought together. So when object B is brought next to object C, well, they also repel. So I have a similar situation than I do in the first scenario. If they repel, they're of the same charge state. Both could be positive, both could be negative, and neither is neutral. Because a neutral object would have attracted to a charged particle. And if both were neutral, they would have just sat there. So now we're left with, what can we say about these three particles? What charges do they have? Well, we can't say whether they're negative or whether they're positive, but we can say that all three are the same. How do we know that all three are the same? Well, if A equals B, those two are the same charge, and B equals C, those two are the same charge, then A has to equal C. And so we know that all three charges are the same charge, and no charge then can be neutral, or no object can be neutral. So what would happen if I put A next to C? Well, if A is next to C, it too is of the same charge as C. So if we put A, just to finish our problem out, next to C, it too will repel. Like charges repel. All right, good job.